webcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone, and welcome to today's webinar, where we will be taking a look at the Creo Complete Machining Package with, as far as the machining extension with Creo 5.0. I apologize, I'm a little tongue-tied this morning. My name is Rob Romanowski. I'm the Director of Sales Operations with 3HTI, and our guests today include Joe DiCarlo, who is a machining specialist and a former applications engineer from PTC, as well as a current principal applications engineer from PTC, Mr. Lee Goodwin. So what I'm going to do is be mindful of everybody's time. This should take about 20 minutes, including questions and answers. And if you have any questions, please type those into the dashboard, and we will answer them at the end of the presentation and overview. So at this time, Lee, I want to thank you again for being on, and I'm going to pass you control.
All righty, appreciate it. Let's see. Get my screen going here.
There we go.
You got it?
We see it.
All right. So welcome, everybody. Again, my name's Lee Goodwin. I'm out of Colorado. PTC, and yeah, so 3HTI asked me to give a little talk today about manufacturing, specifically inside of Creo, and there's tons and tons of stuff we could go through, and I'm not going to go through all of it. I'll let you basically ask questions, after we're done. I'll give you a brief little show of what it looks like. So those of you who haven't ever seen it, those of you who've not seen it in a while, it's going to be pretty different from what we used to have. We've had this product since, I think, 94, as far as an active NC product, and it's come a long way, so as Joe would agree there. But let's take a look at it. Let me change screens, and let's just show it. I've got some PowerPoints, but let's just go ahead and get into it. So this is Creo 5.0. Got a part. In this case, this is a tray for a medical device and so forth. Normal Creo part. So if everybody's used to Creo pieces, you got dimensions and parameters and so forth. No real change there, but that's what I'm going to work with. Now, how do we get going? Well, basically just file new, but instead of part or assembly or drawing, if any of you are used to doing that, I'm going to say manufacturing. So this basically takes me into not only Creo, but specifically into the Creo manufacturing world. So this is something I do all the time. So let's go ahead and just set up our normal vice operation. So something looks like that. And now you'll see I'm in Creo. This is a Creo assembly. I can look at it different ways. In this case, I brought in my vice. This is just a step file I downloaded from Kurt. And then I'm going to tell it what kind of machine are we on. Are we on a mill turn, a lathe, wire EDM? The idea being we can handle, 3, 4, 5 axis mills. We can do mill turn centers, dual spindles, 4 turrets, any sort of machine you want. In this case, I've just got a 5 axis milling machine that I want to work with. And all of these are something you do at once and you store it. So like if you have a standard turret, you can go ahead and set that up so it always comes in that way, or it can be an empty turret. Tools can be solid tools like you see here. Those can be something you create, something you download from a tool vendor, something that you just flat design yourself. It doesn't really matter. Same thing with like probes. I can go ahead and bring those in if I'm going to do some on-machine probing. So that's my setup. And again, I just said, go get my standard, Haas setup or whatever. Then you get working. All right, what are we going to machine? So here's the first difference. If you've got a Creo part, or even if you have a non-Creo, but some sort of imported, notice what I do here. I just say, assemble that piece in. So here's the first no-brainer. If you're working with Creo parts, how nice is it to just say, okay, go get it. There's no translation, there's no step or IGES or anything. Even the assembly here, that's just normal Creo processes. And what that's going to allow me to do then is put a toolpath on this part and know that it's exactly right. It's working on the latest version. It's working on the correct model. There's no translation issues. I'm working on that Creo part. Same thing for the workpiece. In this case, if I had a casting or forging, I could assemble that in. In my case, I'm going to make this out of a billet, so let's just build one right on the fly. So pretty simple stuff there. But now I've got my part, got my workpiece, got a fixture, got my work center set up. Let's go ahead and set up our operation 10. You know, this is going to be the start, so I'll say, yep, use that same fixture setup. The idea is I can have multiple fixture setups. Same thing in the work cell. I could have multiple work cells. I could mill this part and then take it over in a lathe and put it in a different machine. In this case, I'm going to just say, yep, for right here, I want machine 0 to be that corner. Don't care how the part was designed, what are coordinate systems or anything. I just say, do it there. And that's all my setup. So ready to put some tool paths to it. So you'll see here in my assembly, I have all of my milling functions. So you can see I've got mill geometry. In this case, we're going to do a facing operation. So let's just set up a mill window that's top of the part, right? So pretty simple stuff. And again, you don't have to do a whole lot of building because I'm going to work right on this design part. So let's pick a tool. Let's go ahead. Let's set a retract since this is my first sequence. Just give it a safety, something like that. And there's the tool path. So that's the idea. It's just real quickly, put a tool path up there, take a look at it, see if you like it, see if that's the way you want, go make any changes you need, maybe go to the parameters, you know, all the different feed rates and travel and stock allowance and coolant options, whatever changes you need. You also can look at it as a solid. So this is an included simulation. Basically say, show that to me. Run it. You know, let me turn on the parts and really see where we're at. Look for collisions, look for gouges, anything that might be happening that we really don't want to have out on the shop floor. But in this case, there's a face milling. So now I can take that sequence or any one sequence, any 12 sequences, and say, I like that. So let's go ahead and create a template of it. So this allows me to reuse this on any other job. And that's all there is to it. You just say, create a template, one toolpath, a bunch. And that means any new job. So like here, now I need to do a roughing operation. All I have to do is say, okay, let's put another mill window that's right on the top of those bosses and give it a name. What that'll allow me to do then is go get my standard roughing, go get my standard finishing, go get whatever process I've had before. In this case, yeah, let's go get my roughing sequence with a 1/2-inch bullnose cutter. Go ahead and play that. And so just really with one pick, I've said reproduce that tool path, but all it does is bring in strategy, tool, feed, speed, step over. You know, there's unrelated to the geometry. And that's what you really want, is to be able to just real quickly go do it. All right. So there's my second tool path. And again, you just let it run. So at any point I can go back into it. Maybe I want to change it, defaults and so forth. That makes it real easy. But if I like it, want to use it all the time, whatever changes, you just go to it. Same thing, even different scan types and so forth. So, you know, we could spend hours going through all the possibilities for roughing, for surfacing, but everybody'd get bored and go home. So we're not going to do that. Maybe my next step is, okay, here's a flathead mill, go get all the flats. So just bring in that strategy. And again, I don't want to stress, this is my preferred strategy. It's not a PTC thing. It's a tool path I created, and I say, I like that. And then you say, okay, save it. And again, it could be one, it could be a whole part. It could be rough, re-rough, finish, refinish, all in one. Let's go ahead and maybe let's cut out that oval pocket. And I'm going to use a surfacing routine there. So a little something different there. Basically say, okay, start up here at the top. Work your way down to the bottom. And let's do that. Let's do it all as a helical cut. So I'll go ahead and set, let's see, I should set a scallop height. Yeah, something like that. And now I've got a surfacing routine. That looks pretty good there. Again, one continuous helical cut. So again, I can mix and match these that I build manually and these that I build from automated templates. So for example, here, let's go ahead and move this over here. So maybe I want to cut that slot there. Well, I need a flat end mill, but now let's turn it to 4-axis, turn it to 5-axis. So whatever my machine can do, in this case, if I pick this surface, then without doing anything else as far as vector, it's going to say, okay, normal to that part surface. So you can make it as simple, make it as complex. So again, true 4- and 5-axis machining is available. You'll see XYZ now with IJK. Let the system go ahead and figure out that orientation. All I had to do is pick a surface and say, yep, now I got a 4-axis, now I got a 5-axis routine there. Okay, so that looks pretty good. Let me also, again, going back to that design part, notice what happened when I turn on my notes. Well, the engineer put in standard holes there. Well, that means I can use those. I can say, go get my standard, center drill, tap, counterbore sequence for these sort of mounting holes. All I have to do is one pick, grab the template, and there you go. So now I just made 4 new tool paths. Same thing with those little drain holes. Maybe we do those all the time. Well, all I have to do is go get my 370 drain hole sequence, drill them out. So that's because it's accessing the part. It's not just a dumb bit of geometry. It sees sizes, it sees shapes, it sees parameters, it sees callouts. All of that's available when you're staying in the Creo world there. It's really, really nice. A lot of that'll still work just fine also, again, I mentioned earlier, with like IGES and STEP or some sort of translation. Mainly I'd lose the parameters. All right, but notice here, again, I can set what's a safety distance, what's a collision, so I can have all of that come in, avoid those loud noises before you get out to the shop floor. Otherwise, play it, run it. Again, I can stop it at any time. I can speed it up, slow it down. So that looks pretty good. And again, I can go back, look at any collisions or near collisions. This one happens to be good. Looks like I got a couple more walls to get, and I'll be done. So that's good. All right, so that part's pretty close. Let's go ahead and let's save that. Let's talk about next step. Well, I'm going to send this to a given machine. Well, I've obviously got to have a post processor. So this is GPost. This comes with every seat of Creo NC. So you've got a simple, a 3-axis standard mill. You can walk in here in about 5 minutes and have a post. And that's the idea, is you own this. You can add post, change things. How do you want your tool change? How do you want your fixture offsets? But there's also a complete programming language. If you've got pallet changers and bar feeders and swapping and heads and all of that, you can write programs for that. So you can write a post, we can write a post. People like Joe can go in, write you a custom post for any sort of machine. It's really all going to stay in the same family, which is really what you want. And then when you're ready, just say, okay, take this program, let's post it, send it through, turn it into machine code file. Go ahead and give it a name. And then I'll just pick any of those posts that I want. I'll just stick with that number 2. And boom, there's a post. So we've got runtime. Again, there's all sorts of information things I can do. Tell me about this model. Tell me about the operation, what tools were used, what's the total runtime for the whole operation, what's the piece, different pieces. Again, you can break that into different levels, but now you say, yep, this is going to take 30 minutes to run. We're good to go. All right. And that's the basic process. I'm going to work with this and make a tool path. Well, what always happens right about now? You're feeling good. You're programmed. You're ready to go home. Go play softball. Well, you get that call. Wait, you haven't made that part yet, have you? We, the designers, we need to make a change because this is the real world. Customer calls, design calls, whatever. And they say, oh, this pocket needs to be thinner. You know, it's so easy to do inside of Creo, of course. You just change this fillet. It's going to be bigger, smaller, whatever you want to do. So the designer makes those changes, maybe goes in and, you know, let's see, maybe these holes, let's change the pattern. I'm going to turn some more of these off, turn some back on. You know, we don't need all those holes, right? So now your part's changed. What does that mean for you? Well, hopefully you get a ECN, tells you what's changed and so forth. What if they forget something? You know, what if they go into this pocket and say, let's take out 5 10 thousandths. Well, you can't see that. You couldn't compare these models. If he forgets that on the ECN, well, that's the kind of stuff that causes scrap. Well, that's okay, because what's happened here is they've made all these changes to that part. All I do is call this model up. See that pocket? It's, you know, it's 5 10 thousandths changed. Well, it's harder to see, but you can see the holes are different, that big cutout's different, and if we did a measurement, we'd see that pocket operation is 5 10 thousandths smaller. That means my part is going to be correct when I machine it. So it doesn't update until I call it up. That's very intentional. I want to, you know, want the designer to look at it, make sure this is still an appropriate tool to cut that, those sort of things, make those NC programming calls. But the grunt work of, you know, did you drill all the right holes? Well, yeah, it's drilling, in this case, all the 037 holes down on that flat. Whether you add some, delete some, it's still going to do it. And that's really what you want, to be able to respond. You know, if you can respond to your customers that fast to say, yeah, no problem. You know, we made those changes, the tool pass ready to go, we'll go cut another one. That's how you can really, really start making some money. Let me show a couple other things that are all part of this package. So you could do things like, I want to do some probing. So if I've got a probe either on this machine or if I've got a separate CMM, we've got a coordinate measure machine package. Basically allows me to go in and say, okay, probe this face that we just machined. And then maybe go probe the cylinder, something like that. So whether it's, you know, again, in process or after the fact, you just go in and say, yep, I'm going to probe that cylinder and make a tool path, a probe path in this case, that says, yep, go do it. And so I can play the path, I can look for collisions, make sure that size ball is going to fit inside this pocket, all those sorts of things. But then I make measurement statements. And of course, once I've measured something, you know, I've measured that diameter, all I have to do is say, go verify it. Now, where's it going to get the number and the tolerances? Well, it's working on the model. So here it sees that's a 375 hole and it's plus or minus 10 thousandths. That all comes through because you're staying in the system here. So if we look at this code down here at the very bottom, there it is, you know, measure dimensions, measure a diameter, here's the tolerances, all of that came from the model. Everything stays updated. They change those holes. Now my verification, my probing routine is going to update. And again, that's the kind of response time you can get. All right. So let me show again, I just want to run through some models I've already built up. In addition to machining, we have mold package. So you've got a plastic, you've got a casting part, anything like that. Makes it very easy. Let's put it inside of a mold. Let's split it. Let's build parting lines, parting surfaces, gates, runners, whatever you need to do. So now the end result there is Creo models that I can take into NC. This case may be a dual vise. I've got upper and lower. So go machine those things. So it makes it really simple. We also, with Creo 5, added a new NC package specifically for mold machining. And that's what I'm showing here. And the idea is you can mix and match. You can use the old ones, you can use the new ones. But what this specifically does is with this type of geometry, I want to set up high-speed milling. So you can see, let me turn on the target, turn off that tool path. You can see very shallow step depth, but very high speed. Entry exits are defaulting to helical. All the little things that make up high speed milling, we've got packages set up to do that. So if you're primarily doing molds and cavities and positive and negative, we can set you up there. All right. One more general type I should mention, in case I'm sure a lot of you are doing mill turning and so forth. And obviously, you know, 2-axis lathe, we can do that like any other CAM system can do. We're real big on bringing in, especially for turning tools, bring those in from the vendors, you know, go to Sandvik, go to Kennametal, and just download the models right from their library and then go use them. So here, you know, I'm just doing, you know, facing, turning. In this case, this is a mill turn, so I'm going to do some rotary drilling, all those sorts of functions, different pieces, but set it up the way you want, drill out that center hole, and so forth. Cut the flats. Now I've machined away. All right, so mill turn, again, can do multiple spindles, multiple heads. All of that can be done inside of Creo NC. And it's really just a matter of the packages. All right, I'll go back to my last one there. I want to do one thing here, point out this is a Creo assembly. It's got all the manufacturing stuff, but in the sense, it's a Creo assembly. I can make a drawing. So if I need to do a setup sheet that lists my tool table, lists my operations, and then you know, I need to give the operator some dimensions to show what we're working for, you just use regular Creo. You know, it's not like it's a different drafting package. It's the same one your designers are using to create their designs, their pieces there. You just say, okay, I need to dimension the work piece or something like that. Put it up there, and now you've got Creo models. All right? And everything's tied to it. If I go back to, you know, the original model there and add some tool paths and so forth, that's the joy. Even my drawings are going to update. So that's the real key. And again, I could spend weeks and weeks going through all the different tool paths and so forth, but that's the overview of Creo NC. It's really set up for automation, and it's easy automation. It's not something you need a programmer, you know, a C++ or a basic programmer. You just say, nope, use it, reuse it, go find intelligence in the model, build my tool paths, and get her done. All right, Rob, that's about what I had to show. I've got a bunch of PowerPoints, but I figure this is the most important. Show what it looks like there. So do we have any questions?
We do, Lee. Excellent job, by the way. That was a great demo.
Appreciate it.
The first question is, I have an 8-axis dual spindle Swiss lathe. Can Creo do Swiss?
Yes, it can. Exactly right. So basically, and an important piece there is the answer is yes. There's no limitation on the number of axes and so forth. There's always going to be some customization. So, you know, if you're moving in the X-axis, but it's actually going to be a W or whatever, there's going to be some seal command words that you need to add in to be able to do that. So usually that's an implementation process. And again, you know, any of these tool paths I can put in, you know, manual stuff like bar feeds and so forth, things like that. But absolutely, we can do that. Basically work with people like Joe. Let's set up a nice operation depending on what you do, and we can handle those kind of machines.
Excellent. So if there's any other questions, feel free to type those into the dashboard. Joe, just wanted to, I guess, defer to you real quick and see if you had anything that you wanted to add to the capabilities of Creo NC.
Just a couple things that I'd point out that might have gotten overlooked when Lee was going through this. And Lee, excellent demonstration. I know you try to squeeze in a lot in a short amount of time, and you really thoroughly covered a lot of ground. One thing that people may or may not have seen is when Lee was doing the parameters, his step over for his end mills actually had an equal sign before it. So what you can do with a lot of these files, instead of creating a hard value that gets associated to a tool, you can actually create relationships. So basically, as you change the size of your tool, the step over and other parameters inside of the file will change automatically depending, there you go, depending on the tool size. The other thing, I can't stress the importance enough of what Lee said about associativity, which is when the model changes, all the associated documentation and tool paths and where that model is being used update also. In another life, I actually was supervising a department where there were 4 seats of Pro NC, and it wasn't so much that you could initially make your first programs correctly. The big benefit to the package was, because if everybody did everything right the first time, including the engineers, we wouldn't have a problem. But it's when changes came into play, that's really where it accelerated the ability to get parts off the machine quicker, because now we could react more quickly and have those new programs go out to the machine instead of using, you know, second or third package that now you have to update the drawing in AutoCAD and you have to update the machining in Mastercam, and, you know, hopefully it recognizes the changes that were made in Creo. With this, the change is recognized, and a change that's done to the part of the assembly updates wherever it's used everywhere.
Yeah, and one more, Rob, from me then. Also, I'm just really showing Creo NC. Also, where it really shines is once you've tied all this into a Creo install with Windchill, with data management. Mm-hmm. So you don't have that game of, okay, here's this part as a designer, I changed it. I wonder where that manufacturing model is. It's on somebody's desk, you know, it's because it's a third-party CAM and so forth. I can have Windchill say, hey, where is this part used? In addition to showing, you know, the engineering assembly maybe or the drawings, it's going to show me the manufacturing model. It'll say, oh yeah, it's used on 90884. And you go right there, you get update, you get to move.
Next question that came in, can I utilize flexible modeling and design exploration extension with NC, with Creo NC?
So that's a yes and a no. So flex modeling, I can use anytime I'm in part mode. So for those who don't know what flex modeling is basically the ability to move pieces, move geometry and so forth. And, oh, shoot, there you go. Actually, I cannot. That's a great answer. So the idea is, let me show you how you would do that, is I basically would call the part up in its own session and then go ahead and say, okay, recognize this, you know, as a pocket or, you know, cut, and then move it. So this is what flex modeling is I need to move that thing regardless how it was built and so forth. So that allows you to do things like that. So the answer to your question is, I have access to the part. I have access to everything the designer has. So I can make flex modeling changes to the part. I could do it with my fixtures and so forth, but not inside of the Creo NC mode here, I guess is the best way to put it. And design exploration is not available with machining yet. We want to do that. Design exploration basically lets you try a bunch of things and then say, oh, this isn't working. Take me back to the third version without having to do a lot of save as and so forth. So it's a great design exploration tool, but it's not available inside of Creo NC yet.
Per se, Lee, but you can have family of parts and such where you can change parameters and have it update the NC file.
Oh,
so
absolutely.
You can still achieve it in the same desired fashion, but not just going back into your previous history, etc. But you can create families of parts like Rubbermaid. They make one lettuce holder, and then they have drawings and molds and electrodes and tool paths for as fast as they can type in a new height and a new width. They have them all done. So in that regard, yes, but using the specific module design exploration, the answer is currently no. Great point.
And yeah, family tables are so easy. If I have a family table of these parts, all I have to do is say, okay, replace it, go get a different one. And then it'll basically swap that part out, put the new one in, redo the tool paths, you're good to go. So.
Thanks, Jim. Jim, is there anything else you'd like to add?
Yeah, Joe brought it up. I think Lee said it. The key here is automation, automation, automation. You know, once you do something once, you'll never have to do it again. If you do it again, shame on you, because your tool paths adapt to new geometry. They adapt automatically to change. That's the term that Joe used, called associativity. And it just enables customers to get their parts and molds and whatever out better, faster, cheaper. You know, with eliminating or minimizing mistakes. So, you know, that's really it. Once you do it once, you'll never do it again. And the people that really embrace this tool and understand it. And the one thing to note, I mean, we're showing this in Creo, but I have mold shops and machine shops that take in parts from every CAD CAM system and at STEP and IGES as well. And they get the same automation and the same, you know, process automation that you get with native Creo. Creo doesn't care where the geometry comes from. It really doesn't. That's the beautiful thing about it.
Next question that came in is, can we use Pro Program with NC?
Yes, I haven't done that in a long time, but there should be no reason you can't do that. Absolutely. Yep, Pro Program. So we got, somebody's asking questions from deep in the past, but the answer is absolutely.
So for people that don't know what Pro Program is, it's basically configurations. You know, you can do multiple configurations in Creo. You know, it used to be called Pro Engineer, but if then else logic, and it makes the changes and all that stuff for you based on your logic. So it's logical programming.
Yeah, the example I've had used before is one of the oil field companies was doing turning on a ring that just had 7, 8, 9, 10 features, but they made over 1,000 different versions of those. So they used family tables to swap the parts out, and then used Pro Program to choose from like one of 6 work pieces, you know, billets that they started from, and basically put the new part in, let it look at, see what's this, okay, this should go to this one. Yep, that kind of automation.
Yep. So, and an example there would be, yes, if the OD is greater than this, choose this billet.
Yeah, that kind of stuff.
That's great point, Lee. Great point.
Nice. Well, that's it for the questions. And what I'm going to do is I'm going to take control back for a quick second before we go. So I want to thank our panelists, Jim Gilmore and Joe DiCarlo, and also Lee Goodwin for doing the presentation for us. If you need to see anything more detailed, a more detailed demonstration of Creo NC, feel free to contact us at info@3HTI or give us a call toll free. You can also just simply respond to the emails that have been sent out inviting you to this webinar. They will come back directly to me, and I'll get you in touch with the appropriate person to help figure out what exactly you need to see specifically in Creo NC, and we will set up a demonstration for you. So once again, I want to thank our panelists and thank everyone for being on today. And this is going to conclude our webinar. Have a great day, everybody. Take care.